get started? Okay, so everyone's assignments are in. You will, it takes the TA a while to mark it, so a TA will mark it, not me. And as you can imagine, your assignment was probably a couple pages long, and you have 100 students, and all of a sudden you have 500 pages. So usually takes about 2 weeks from when you submitted it. So from last Friday if you slipped. So you can expect your mark sometime in that window. You'll get them back through EAS itself. So you should get an email or something saying that your grade is on EAS, and then you can check the marks themselves. Yeah, so that's it. Is there any questions about anything before? We haven't seen each other in 2 weeks. Okay. All right, well, let's try and refresh ourselves in terms of what we were talking about. All right, so last class we talked about certificates. We said that there's a bunch of checks that have to happen client side to make sure that a certificate is valid, including that it's signed by the proper, someone that's actually a CA or that has been delegated to be a CA. You can trace it back to a root CA that's on your computer. The certificate is actually for the website that you're visiting. It's not for some other random website. All the certificate authority certificates in the chain are actually certificate authorities. We talked a bit about this notion that certificates could expire. And then we also mentioned that certificates could be revoked, okay, but we didn't detail what revocation means. So now we'll pick up with revocation. Okay, so the basic question is, you have a certificate. The certificate allows you to make secure connections to your user. No adversary can eavesdrop. The reason they can't eavesdrop is because they don't control the private key that's inside your certificate, right? So your certificate has this public key. Your users are using that public key in order to construct this tunnel. The adversary doesn't know what that public key is, so they can't insert themselves in the middle. Now, that private key that corresponds to the public key, it has to be somewhere. It has to be sitting in memory. So we saw with Heartbleed, for example, that's an attack where if I can go into memory, I can grab your private key out of memory. Now I can impersonate you, okay? So whether it's through Heartbleed or it's through any other attack that lets me compromise your private key, there is the chance that private keys get compromised, right? Or maybe employees know them and then they get fired, and then you want to change your private key. There's all sorts of different scenarios, okay? So the question is then what happens? Okay, so you're a website, you have a certificate, somehow you learn that your private key was compromised, and it's out there in the wild and adversaries are using it. What can you do about that situation, okay? And so the idea is that we need some way to revoke a certificate that's been issued, okay? So we call this revocation. So it's a way to sort of cancel a certificate once it's been issued. So compromise here means, if you want to be very specific, it's like someone stole the private key. So Heartbleed would be one example. Could be malware, could be like an insider threat, or use your imagination. Could be a crypto attack, whatever. Somehow it gets compromised. Okay, and so the basic attack is really simple, but we'll just draw it out. So the user says, hey, I want to do HTTPS with you. Can you send me your certificate? And the server's like, okay, no problem. I have a brand new certificate. I was breached last week, but it's no problem. I went back to my CA and I got a new certificate. Okay, that's easy. So you can replace a certificate. You can get a new one. Okay, so that's not what we're talking about here. So here you can send your new certificate. But if the adversary who has your old certificate is on the line, then they can just replace it with the old compromised certificate. Okay, so just because the CA will issue a new certificate, that's fine, that's great. But it doesn't take the old certificate out of circulation. Okay, so it doesn't cancel or revoke the old certificate. And so now you just have two certificates. They're both valid. One of them only the website knows, the other one the adversary knows, right? And so that's not a solution to the problem. It's just like reissuing a new certificate, okay? We need a way to actually cancel this old certificate and stop it so that when the adversary shows it to the user, somehow the user says, oh no, I'm not going to accept that certificate because that certificate was canceled or revoked, okay? Okay, so there's a couple ways of doing it. This is the most common way, and it's called a status check. And basically what it says is when the user receives a certificate, they do all the normal checks, okay? So everything is fine, it's valid, it's signed correctly, et cetera, okay? Then they're going to do one final check, which is they're going to go ask someone whether this certificate has been revoked or not, okay? So that's the basic idea. And we'll think about who's going to answer this question for them, okay? Okay, now who are they going to ask? And how are they going to ask them, and what does that look like? The person that they're going to ask is actually, they're going to find it in the certificate itself. So when you're issued a certificate, you sort of choose who you want to answer questions about the revocation status of your certificate. And by default, it's basically the CA that gives you the certificate. So if I go to GoDaddy and I get a certificate from GoDaddy, GoDaddy's going to put up a server. So this is all fully automated. It's just a computer. And it's going to answer questions about my certificate. So every time someone sees my certificate, they're going to go over to GoDaddy and say, hey, I just got this certificate. Is it still valid? Has it been revoked yet? And then the server is just going to say yes or no. Okay. So this is going to be a server. Specified in the certificate. And typically it's the CA that signed the certificate. Okay. So this protocol is called OCSP. I just note that because I'll show you the certificate where to find it. So you have to look, you have to know what it's called to know where to look. So it's called OCSP, which stands for Online Certificate. Status Protocol. Okay. So online means, you're asking in real time. You just received the certificate, so you're going to ask about it. Certificate status is just whether it's revoked or not. So it's basically just going to send you yes or no. That's all it's going to say. And then protocol meaning that, it's an interaction between a client and a server. Okay, so let's go to whatever, Concordia. So Concordia is served over HTTPS. We have a certificate. So we'll look at the site certificate. So the site certificate is issued by a CA called Global Sign. And if we go into the details, we see somewhere in it, OCSP, Online Certificate Status Protocol, and then there's a URL. So you might not be able to see it, it's pretty small, but it's http://ocsp.globalsign.com. So that's the CA that's issuing it, / like a bunch of stuff, but it doesn't really matter. Okay, so let's think about this protocol and how secure it is. So I'll split it into issues and attacks. So some of them are more like issues rather than attacks, and some of them are attacks. Okay, so the first issue with this is a sort of practical issue. Let's say that you're the CA and you land Google as your client. So that's great. Google's a big company, probably will pay you lots of money. So you're really excited to be the CA for Google. So you issue a Google certificate. All right. Now what happens is you put up your server, your OCSP server, right? Now every time anyone in the world goes to Google, they're going to hit your server as well, right? So there's probably billions, millions, if not billions of people across a day that hit some Google resource, whether it's Google search or Gmail or whatever, and every single one of them is coming to your server as well, okay? And so your infrastructure doesn't have to be as big as Google's because you're just giving them a short response, but it still needs to be pretty big, okay? You have to be prepared. Now, let's say that you're the CA for Google and Facebook and Twitter, right? Congrats to you, but your server is going to get hammered, right? So every time one of the users goes, it's not literally every time, so your browser will ask for the certificate and then it will kind of remember it for a while, okay? So, but still, you're getting a ton of traffic, okay? So you receive, let me be more specific about who this is. So the OCSP responder receives traffic every time someone visits, for the first time, but we'll just say visits, a website using a certificate that you issued. So the sum of all the sites that you issued a certificate for. Okay, so what happened is this was a great idea in theory. They put it out in practice, and the CAs for Google just couldn't keep up with the traffic, okay? And so then what happened is you would ask an OCSP responder and you just wouldn't get a response, okay? Or you would wait. You'd wait 5 minutes and you get a response after 5 minutes or something like that, okay? Now, remember, like when you go to a website, you're weaving together content from lots of different websites. And so you don't want to sit there and wait for like the slowest certificate. Like if say you pull resources from 20 websites and you get an OCSP response quickly for 19 of the 20, but one of them you're waiting 4 minutes, well, that's 4 minutes you have to wait for the whole web page to load, okay? And so users don't want that, all right? Sorry?
User end up not using that data.
Yeah, exactly. Yeah, so the user will go somewhere else, right? So now the browsers were caught in they were sort of caught in a hard place. They had to choose between security. We really want to wait and make sure that these certificates aren't revoked, or between usability, right? Our users don't want to wait 5 minutes, and so we're just going to try the best we can. We'll ask the question, is this certificate revoked? And if we don't hear back, then we'll just assume that everything's okay. Okay? So browsers for the longest time did the second option. Now, we're slowly trying to reintegrate. So we have these new certificates that are coming out, and they're sort of a higher tier certificate. And one of the requirements is you have to have a server, and it's got to be live and all of that stuff. So slowly over time, we're trying to reclaim this protocol. But for many years, this protocol would, as what we call in security is we'd say it fails open. Meaning it would try, and if it didn't get a response, then it would just assume everything's good, as opposed to assuming everything is bad. So once again, I'll try and be specific. So the browser will assume certificate is okay if it doesn't get a response. Okay, so let's go back and look at this picture. Okay, so let's say you're the adversary, you're in the middle. So this user goes to the website and they say, what's your certificate? And you, as the adversary, have a compromised certificate, okay? Now you're kind of out of luck because the website went and revoked that certificate and they got issued a new certificate, okay? So you're sitting in the middle, and so the user asks for the certificate, the website sends its new certificate, and you're going to drop into this connection the old compromised certificate. But now your problem is that it's revoked. Okay, so you shouldn't be able to get away with it. Okay, so what happens? So you put the revoked certificate, it goes to the user. Now the user is going to go to the CA and say, is this certificate valid or not? Okay, because there's nothing invalid about the certificate itself. It checks out, like it's signed, it was a valid certificate, it's just been revoked. Okay. So then the user has to go and they're going to go ask the CA. Now let's say you're the adversary and you're in the middle between the user and the CA as well. What are you going to do? The user is going to say, hey, is this certificate revoked? If you let that message go through, the CA is going to say, yes, it's revoked. Try and send that back to the user. Are you going to let that message through? No. Okay, what if you just drop it? Then the browser is going to hang on for a second, and it's going to say, oh, I didn't get a response. CA server is probably too busy, right? And so I'm just going to assume that the certificate's okay. Okay? And so that's literally what happens. Okay, so a revoked certificate doesn't mean anything really. If you have a true in the middle adversary who's in the middle both between the connection between you and the compromised website and between you and the CA, you're out of luck because your browser is going to, it's going to assume when it doesn't hear back that the certificate is okay. Okay, so the browser fails open, which means it accepts the revoked certificate. Or it doesn't, a better way of putting it is it doesn't learn that it's been revoked. If the browser ever learns once that it's been revoked, it will remember that information forever, okay? So the adversary has to be persistent. They have to either get you on the first time you ask about that certificate, or they have to be persistent and always, dropping that response, okay? Yeah, thanks. I always reverse them. Or no, it's OCSP. Yeah, it is. Yeah. I do reverse it all the time though, but it actually is OC. Yeah. Okay, now the user says, okay, that's really scary. You know what? Now you've scared me so much that I'm going to go into my browser and I'm going to find the setting that says don't fail open, right? Wait for those OCSP responses, and if they take 5 seconds, they take 5 seconds. And if you never hear back, then just don't load the page or load it without the lock or something like that, and try and show me that there's something wrong, and I'll make a decision at the time. Okay, and so that's fine. Browsers have this. These are defaults in your browser. You can override it, so you can go in and you can check it so that you're always checking these responses. Okay, so then the adversary can't drop it anymore. If they drop it, then the browser will not. It's not going to fail open. It's going to fail closed. It's going to assume that it's revoked because it didn't hear. Okay, so is there anything the adversary can still do? Okay, so look at the address of the responder and tell me if anything jumps out. Okay, so this is over HTTP. So let's set aside the question of why. Okay, I'll answer that in a second, but let's just think what's the consequences of that. Okay, so now the user goes, they ask for the certificate, the website sends the new certificate, the adversary sends the compromised certificate instead. The user goes to the CA and they say, is this certificate valid? Okay. The adversary, they can't drop that message. So they let the message go through. The CA comes back and says, actually, that's revoked. Okay. Can the adversary, if they drop it, then the browser is going to assume the worst, right? So they can't drop it. Could they change it? What if they just change the yes to a no? Yeah, it's been revoked, and they change it to no, it's not been revoked. What stops them from making that change? Encryption or signatures or HTTPS. So if this check was done over HTTPS, then they couldn't change that information, right? The best they could do is drop it, but then it would fail closed, okay? But because this is over HTTP, they can just change it, okay? So even if you go in and turn that browser setting on, it doesn't actually protect you. It just means the adversary, instead of dropping everything, they're just going to change the yeses to nos. Okay. Now the next question is, you're thinking, well, why isn't it over HTTPS, right? That seems pretty stupid. And so I'll answer that question in a second, but let's just note it. Okay, then the last question is, well, why HTTP? Can we just solve it by making it over HTTPS? Okay, if we fix the browser so that it fails closed, and we do this over HTTPS, then that's fine. That actually is sufficient. That's a revocation protocol that would work. Maybe for performance reasons you have trouble, but there's no security problem with it. So why can't we just make this HTTPS? Okay, so let's think through the flow of what would happen if we made it HTTPS. So we go to the website, we'd say, I want to talk HTTPS, give me the certificate. And the website will say, here's my new certificate. And the adversary drops in the old revoked certificate. Okay? Now you're going to go, and you're going to go to the CA's OCSP server. And you're going to say, you want to say, is this certificate revoked or not? But now I'm forcing you to do it over HTTPS. So before you can even ask the question, you have to say, hey, I want to do HTTPS. And the OCSP server will say, great, here's my certificate. It sends the certificate down. Then you say, oh, is this certificate revoked or not? Well, let's go check through OCSP whether it's revoked or not. And so you look up the OCSP server and you see another HTTPS server. So then you go over to that server and you say, hey, I want to do HTTPS. And it says, great, here's my certificate. And then you're like, oh, now I got to check whether this is revoked. Okay? And so you end up in this circular loop where you're just checking certificates. You can never actually start having the conversation because you get stuck, checking certificates forever. Okay? And you can't get out of it. So that's why you can't do HTTPS with this protocol. Okay, so OCSP basically doesn't work very well. And the consequence for it is revocation on the internet doesn't work very well. Okay, it's sort of a best effort. There is a chance that you ask and maybe the adversary isn't present at that particular time, or they're only on your connection to the website, they're not on the connection. Like say they're local to the website that's being attacked, they're not local to you, then maybe you could get a conversation with the CA that they're not on. Like, so just because you're in the middle of one conversation between a client and one server doesn't mean you're, in the middle of all conversations between that client and every server they might talk to. Okay. So anyway, so revocation is better than doing nothing, but essentially it doesn't work. Now there's a second option that also, it works in theory, but it just doesn't work that well in practice. And the second option is that CAs could periodically just say, here's a list of all the certificates we've revoked, okay? So we move away from this online, I just received a certificate, I'm going to check it in real time. So you don't have that problem of someone pinging it every time. What you instead have is the CA puts up a list, they update it every 3 days, and so if your browser sees a certificate, any certificate from that CA, then they'll just and they're like, I haven't checked that in 4 days. Then they'll head over, they'll get the latest list, and then they'll check the list, and then they'll hang on to it for the next 3 days or whatever. Okay. So these are called certificate revocation lists, or CRL. Actually, let me put it like this. Yeah, okay, that's fine. Actually, browser. So every 3 days or something like that. You don't have this circular loop problem, so the CA can sign the list. They just sign it with the same key that they're using to sign the certificate. Now, if a CA is compromised, right, then it can't revoke, like then the revocation list is also compromised, okay? And so what happens in these cases is it's always the parent in the chain that revokes for the children. So if a website is compromised, the CA that issued it is going to revoke the certificate. If a CA certificate is revoked, you need the certificate that's higher up in the chain to do the revocation. Okay, so they're going to issue the list. Now you might say, well, what if a root certificate is is compromised and you need to revoke it? Then you're out of luck, right? There's no one higher than a root certificate to do that revocation. But it would be such a big deal that Apple, Microsoft would issue a software update where they would remove that root certificate from the operating system, right? So the ultimate fallback is that you actually change the browser or the operating system. And you can also revoke like site certificates that way as well. So if it's a really high profile revocation, like for example, let's say that Google, they somehow noticed that one of their certificates was compromised. Or say that there's a bad CA out there that's issuing certificates for Google and they somehow notice it, right? They control a popular operating system, Android, right? So they can just, they can deny list that right in Android itself, right? And so they don't have to worry about the CAs, and obviously they want the CAs to revoke it and all that stuff, right? And then everyone that uses Chrome, whatever platform you're on, you can write that rule into Chrome as well, okay? So you can always take a heavier handed approach of trying to block it at the level of the browser or the operating system. But anyways, there is this whole CA process that's in place as well. Okay, and so CRLs are also, you can find where they are in the certificate. So not all certificate authorities use them, but most of them do. Okay, so this is where you would go find it. It's basically a very similar URL, just has CRL instead of OCSP. Here, it's still going over HTTP, so that's kind of problematic. But the point is that this file itself will be signed. So there will be a signature on the data itself. That sort of protects against this. And then a third option, which maybe I'll call it 2B because it's basically the same as 2, is instead of every user going to every CA and getting the lists and things like that, what some browsers like Chrome will do is they say, we're going to do that work for you, okay? So Google themselves will go every day or whatever to all the CAs that it knows about anyways, and it will get all the CRLs, it will repackage it, and it will send it to you in Chrome. So when you connect Chrome to the internet, it's not technically a software update because you don't have to update it, but your browser will just go over to Google servers and say, hey, give me the latest CRL set. And then and so that's just curated by Google itself, okay? And so Google's distributing it to all the Chrome users. It relieves the burden on the CAs, because Google just has to get it once from the CAs and then it can give it to all the Chrome users. Of course, they're setting up that infrastructure, but it's built into their revenue model of trying to get users to use Chrome because it has different security advantages and things like that. So the browser, okay, so sorry, the browser's not collecting it, but they'll have Google. Say on the user's behalf. and then Google just sends it to you. And if you care about things like data structures, there's some cool things. They use these like Bloom filters, and there was even a proposal for a double Bloom filter. But anyways, it can give you the information in a very compact form, so that you don't even need the list. You just have this data structure that you can take the certificate you're looking at, kind of hash it, and send it to the data structure, and it will say yes or no, it's been revoked. Okay, and then I don't have any recent data on this, but there was a study that happened, I'm going to say about 10 years ago. And it basically found that the coverage was low. I forget what it was, but of all the certificates that could potentially be revoked, these CRL lists don't include all of them for reasons I don't fully understand, but the coverage was something like 20% or something like that. So it was a really nice idea, but CAs just aren't populating CRL. So I think the experiment was, let's go ask them over OCSP, wait for the response, and then if they say it's been revoked, we'll check the CRL. And they found that for a lot of these, either it wasn't included in the CRL, or maybe it was that Google wasn't hitting all the CAs. So, Google was only hitting the top 50 CAs, but there's hundreds of CAs or something like that. I forget what the source was, but the coverage was low. So hopefully this has been fixed, but I haven't seen any recent data on it. Yeah.
I thought you mentioned that the CRL list is using OCSP. I thought you mentioned that it's usually signed, like for the option 2, right?
Yeah.
So the communication is usually in HTTPS, so it doesn't, but the screenshot it's showing in HTTP, like this.
Yeah. So the signature is on the file itself,
Okay.
and it's not in HTTPS itself.
Okay.
Yeah. So I'll put it like this so it's clear. Okay, another attack you can do, and we're trying to wrap this up quickly, is, I think we mentioned this before, you can use no certificate. So let me back up. So we're done with revocation now. So that's revocation. Revocation kind of works. It's kind of broken. If you're an adversary, you're able to steal a certificate or get issued a certificate, and it gets revoked, then you're not completely out of luck, right? There's a chance that you can still go around, use the revoked certificate, and then try and disrupt the user from learning that the certificate is revoked. Okay, now another high-level attack is that you can, just an attack on HTTPS itself, is you can use no certificate at all. And there's a simple way, so we mentioned, okay, so the attack that we mentioned is slightly different. We mentioned one where you just make up a certificate and it's wrong, and the browser says it's wrong, and you just hope that users click through, okay? So that's a really simple attack that you can do. In this case, what we're going to do is we're going to try to prevent the user from ever going to HTTPS in the first place, okay? And it turns out to be easier than it sounds. So this is called SSL stripping. And it's very simple attack, but it's consequential. Okay, and this also is a somewhat historic example. So I looked last time I taught the course for an example, but most of the websites have fixed it. So I'm just going to draw out an example that's sort of fictitious. Okay, so a lot of websites used to follow this sort of architecture. What they would do is like pretend it was like a newspaper website, like the New York Times or something like that. Okay, you would go to the website and it would be over HTTP. Okay, so they would just give you an HTTP website, but then somewhere on the website they might want you to log in, you know, because you have a user account for whatever, maybe for your digital subscription to the New York Times, and it has your credit card information and stuff like that. Okay, so what they'll do is they'll have, you know, maybe at the top of the screen in the top right corner or something like that, they'll have like a little login thing. So you can put your username, you can put your password in, and then there's a submit button. And when you press the submit button, it posts the information that's in those two fields. Okay. Now you might say, well, you don't want to send your password over HTTP, right? So if I see a website and it comes down and it's over HTTP, and I put my username and password and hit submit, does the password go over HTTP or not? Okay, so by default it would go over HTTP. Is there any way to force the password to go over HTTPS, right? Even if the whole website was HTTP. So when I program, like in HTML, that submit button, I just give an instruction, it's called a post message, and I just say, you know, here's the two fields, and I want to send it to this URL, okay? So take whatever is sitting in the username field and in that password field, and send it to this address, okay? That's what I write in HTML. And in that address, I can put HTTPS, okay? So 99% of websites, that's how they would work. You would get the page, it would come over the web on HTTP, but that submit button is wired to their HTTPS server, okay? So as soon as you press the button, then you can tell, because then it will log you in, and then when you're redirected, like when you go to the page after you logged in, it will now be on HTTPS, okay? So it will redirect you to HTTPS. So the submit button goes over HTTPS. And it's basically because there's a reference, a URL inside, you know, this post message that basically says post to this URL, and it can be whatever, HTTPS secure.site.com or whatever the case may be. Okay, and so websites did this because, you know, they don't want to load all their pictures over HTTPS, because it used to be that there was a penalty for doing that because it was encrypted, and who cares? You're reading the news, you don't need privacy, so we don't care about it. But you're going to submit your password, then we care, right? Because if we do that over HTTP, then someone can steal your password, they could steal your credit card information or something like that if it was stored in the account. And so this is what they would present the user with, okay? Now, how does the user know whether pressing that submit button will go over HTTP or HTTPS?
At the bottom corner, it sometimes displays.
Okay, so you could try and hover your mouse over the button, and sometimes it will show you the URL that it's going to. Let's say that that doesn't work. What if there was like a lock, like it said submit and then there was a lock beside it? Like on the website, like a picture of a lock. Okay, people are nodding their heads, but does that actually prove anything?
No.
Okay, so if there's a submit and there's a little picture of a lock, that doesn't mean anything. That's just a picture that the people put on the website. Okay. All right, so the answer is there's really no way to tell unless if you looked at the HTML, right? So you could click on it and go to view source and then find that button element and then see what URL it's going to. Otherwise, you have no idea, okay? So most users are just going to cross their fingers, or like last time I did it, it went to HTTPS. Most users won't even know, like they won't even notice, period. But basically, you're going to cross your fingers, you're going to press the button, and then hope that it goes to HTTPS. And if you're wrong, it's too late, right? Your password's gone already, okay? Okay, so there's no way to tell if the submit button will post over HTTP instead of HTTPS, except for looking at the HTML file. And there's one other thing. So your browser will actually warn you the first time you try and post information over HTTP. And you've seen this message, everyone in this room's seen it, whether you remember it or not, okay? And you probably clicked don't warn me in the future because that's an option, okay? But it basically says something like, hey, you're about to post information unencrypted, are you sure you want to do it? And usually you're doing it because you're posting something like where you don't care about encryption. It's not your password, right? So the browser doesn't know, oh, you're about to submit a password, that's really important that it's encrypted. It just knows that you're calling this post command and you're sending some data. And there's a lot of times where you send data and you just don't care about whether it's encrypted or not, right? So usually the very first time you don't care because it's not a security sensitive task. And so then you say, don't warn me again. And then when it comes time to submit your password, then there's no warning anymore because you dismissed it, okay? Yeah, so the first time you submit over HTTP, or you post over HTTP. Post is like the sort of technical term for that kind of, like normally you fetch HTML, but then posting is like you're sending, fetching's like give me this, and then posting's like here's this information. And there's other stuff beyond that, but yeah.
Sometimes when we go to that kind of website where it is not secure, but we have HTTPS, so what is that?
So if you have HTTPS on the base page, right, you could still, in theory, like you could wire your submit button up to HTTP, right? And in that case, yeah, then your information would go over HTTP instead. And so that's, so the attacks I'm thinking of is where the developer of the website isn't evil, right? So if the developer wants to trick you, they can get your password. I mean, your password's going to them anyways, right? So anyway, so we're sort of setting aside the like bad designed website. Now, of course, it could be that someone breaches the website and then they change the functionality of it, right? But you can also like, if you have JavaScript running on this, you can just leak the password. Like there's a million ways of getting a password if you can control the website itself. But what we have in this flip scenario is, in this case, the developer is doing everything right? Like this submit button really does go over HTTPS. And so there's no reason why this shouldn't be secure, even if it's not usable. Make sense? Okay. Yeah.
So a website like this which has content that's loading on HTTP and the username password loading on HTTPS, will it have a secure lock symbol on the URL?
It will not. So the URL, because the landing page, the base page comes over HTTPS, there will be no lock. So the lock only applies to the main page itself. And then there's some ways of like having the main page come down, but then let's say you load JavaScript, then it's going to take the lock off kind of thing. So it's necessary but not sufficient that the landing page comes down over HTTPS to see the lock. But if the landing page doesn't come down over HTTPS, there's going to be no lock, even if most of the content comes over HTTP. Okay, or over HTTPS. And we'll see why. This is actually the nature of the attack. And once you see the attack, you'll agree that it should never show the lock in this case. Okay, so let's say you're an adversary and you want to attack this website. Okay, once the user puts their username and password in, it goes over HTTPS, right? So you're out of luck. You're not going to read the password, but you do want to. You're in the middle and you want to read the passwords. Okay, is there anything else you could do? How else could I get this password?
You can modify the base page and we can get the password as HTTP and
Okay.
post in HTTP.
Okay, so the only reason the submit button is going over HTTPS is because the HTML says it has the URL and the URL is in HTTPS, right? But where did that URL come from? It came from the HTML file. Where did the HTML file, how did the user get the HTML file? Well, it came over HTTP, okay, which means it can be modified, okay? And so the modification you can do is actually really, really simple. Is you just put up a man-in-the-middle like server, and it says every HTML file that you see go by, anywhere you see HTTPS, just replace it with HTTP. Okay? So all the URLs that go by, they're all coming down from the server with a bunch of references to HTTPS. They hit your man-in-the-middle box, and it turns them all to HTTP. The user gets a website. It looks exactly the same. Okay, the only difference is now when you hit the submit button, it goes over HTTP. And as we said, you can't tell the difference as a user unless if you're going and inspecting the HTML code itself, right? So you're never going to notice the difference, okay? So it's a really simple attack to implement, but it basically does the job for you, okay? And so how do you circumvent this attack? The answer is that you need to send the root page down over HTTPS, okay? You can't have the user go to HTTP and then refer them later to HTTPS once you decide that they're doing something secure, okay? You need to start with it being secure because that switch over to HTTPS is being served over HTTP in this case, okay? If it's served over HTTP, then it can be changed so the switch never happens. So the only guarantee that you can have that that switch happens is if the switch itself is protected by HTTPS. Does that make sense? Okay. So this is why, like I said, I have a hard time finding examples now because websites have grown up to this fact. And so most websites, Montreal Gazette, CBC, New York Times, whatever, you go to it, it's HTTPS now right from the landing page, okay? Even if you're not logged in, you're not doing anything, it's over HTTPS. Okay, so they call it SSL stripping, which is the bot that sits in the middle. And so basically the user will never leave HTTP. They'll be stuck on HTTP forever. So the solution is serve content over HTTPS only. Don't switch. Okay, so we could call this actually, maybe I'll put this in and then next year I'll incorporate it. We'll call this switch to HTTPS sort of template. A few other sort of esoteric attacks. I would just want to show you like all the different kinds of attacks so that you get a sense of how broad it is to attack HTTPS. Another one that was kind of cool is called picture-in-picture. Also doesn't work so well today because of changes made in the browser. All right, so you go to a website and you're enticed to to go there because of the adversary. So they send a phishing email or something, I don't know, whatever. Somehow you end up on the adversary's website, and they want you to like their content, so they have a Facebook like button, but you're not signed in, so they have somewhere on this field like a sign in to Facebook kind of button. Okay, you click the sign into Facebook button against your best judgment. But don't worry, actually what pops up is you have a window from Facebook, you know, whatever, asking for your username and password. And this window is actually from Facebook, and it even has, it's over HTTPS, so it has the lock or whatever. Okay, so if you're on a bad website and they launch a new window, and the new window is to the correct URL, you check it out, and there's actually a lock and things like that, is it actually safe to put your username password into it? So if the certificate is correct and the URL is correct, it doesn't matter that you were redirected there from a bad website, okay? HTTPS protects you. It says you have a tunnel to Facebook, so it doesn't matter who told you about it or whatever. The tunnel's there, and so they can't do anything bad, okay? Now the nature of this attack, so this theoretically is okay. You could actually put your username password into that, and it would be possible. But that's premised on the fact that this is actually a true browser window, and that certificate is right, and that URL is right, okay? But because this pop-up window is completely contained visually, it's completely contained within this website, how do you know that it's not actually the website, it's the content of the website itself that's made to look like a browser window, right? Like a browser window has a certain look to it, but I can take a picture of what a browser window looks like, right? And I can load that as a JPEG on my website, and it kind of looks like there's a browser window sitting there. And even with some fancy JavaScript, I can make it so that if you dragged it around, it might even drag around on the website. Obviously, I couldn't drag it outside of what we call the Chrome of the browser, so I can drag it outside the window, that wouldn't work, okay? But a pop-up might actually be the content of the website as opposed to an actual content itself, okay? So we call that a picture-in-picture attack, where basically it's a fake pop-up. And it's actually part of the website, like an image on it. And then of course you can put the lock there, right? And you can make the lock look exactly like the real browser lock, but it doesn't mean anything because it's just a picture of a lock, okay? And so then if you put your username password into this fake pop-up window, then the adversary can capture it. Okay, and so I said this doesn't work so well anymore. And the reason is that browsers now really don't use pop-ups. Okay, what they'll do is they'll force a new tab instead. Okay, and a new tab you can't fake, right? Because you have the tab bar. The tab bar is part of the browser, and so I mean you could have a tab bar and then a fake tab bar underneath it or something like. Maybe there's some way, but it would look suspicious anyway. Okay, so the response is to force new windows or new tabs. Instead of a pop-up. So a pop-up means like a smaller window that's sort of overlaid on the current window. Now the real reason that browsers did this is because there was a lot of websites that were really annoying. You would go to them and they would open like a million pop-ups, right? And then the browser said, by default, if a website wants to open a bunch of new tabs, you're not going to let it, right? So sometimes you're on, I don't know, My Concordia or something, it wants to open up a pop-up, and your browser's like, no, I'm not going to open that for you, and then you have to override it. Like there's usually a little icon you can click it that says allow it, and you can make it sticky so that it always allows pop-ups for that website or whatever. But anyways, so this attack kind of went away when pop-ups themselves went away. Okay, now let's go back to the attack tree. Instead of logging through Moodle, because I'm going to have to do two-factor authentication, all that stuff, I'll just pull up an old version of the course that has more or less the same tree. Okay, so we talked about most of this stuff. So remember early we talked about recovering the key, and we had all these attacks. We didn't really go through all the details. We talked about the fact that just because it's encrypted traffic doesn't mean you can't learn anything. And then we talked about how you're going to get the tunnel pointed at you, okay? And so today we said, well, if you could use a revoke certificate, if you could get one somehow. The fact that it's revoked doesn't really mean much because you can just drop the OCSP response and it will fail open. You can not have a certificate, and so you could do SSL stripping, or you could do this picture-in-picture attack. So those are examples of no certificates. Last class we talked a little bit about you could just use an invalid certificate, so you could either tolerate the error, meaning that hope users click through the error. If there's some sort of implementation error in the certificate checks, like you're not checking the basic constraint that a CA certificate is a CA. In go-to-fail, you weren't checking that the domain matched the certificate. There was those weird parsing errors with null characters, right? All of that stuff basically allows you to use an invalid certificate. Then you can get the tunnel pointed at you, and then you can achieve the ultimate goal. And then earlier we talked a bit about using valid certificates. So we talked about subverting how you issue the certificate. So when it's automated and sent over email, for example, there was a bunch of different attacks. In person for an EV certificate, you can use social engineering. You could do, if you're a government and you have a CA that's in your legal jurisdiction, you could just say, hey, give me your key, and they might have to do it. Intersection proxies we didn't talk about, so you can just skip those. And another simple attack that I'm remiss that I probably missed it because I can't remember us actually talking about it. But I should have brought it up when we saw we sort of talked in theory when we saw all the different certificate authorities, and we saw that there were hundreds of them. And I said, you can attack the weakest link. But what I didn't mention is that certificate authorities have been attacked in the past. So two high-profile cases happened around the same time. One was called DigiNotar and one was called Komodo. And probably not coincidentally, but my understanding of the history of this is Google decided one day, they woke up and said, okay, what we're going to do for Chrome is we know our own certificates. We're Google. We know what our certificates look like. And so what we're going to do is we're just going to watch and see if we ever see a Google certificate that's not a real certificate. Okay, if any of our Chrome users goes to a Google website and gets a certificate that's not one of our actual certificates, we're going to note it, and we're actually going to phone home. So that browser is going to send a message to Google headquarters saying, this is a certificate that I just saw. So Google kind of quietly did this. They turned the functionality on. Everyone upgraded their browsers. And then immediately, people realized that, hey, there's a bunch of Google certificates that are floating out there that are invalid. Some of them are coming from this DigiNotar, and some of them are coming from Komodo. And so what had happened is that someone basically just breached the CA. They didn't steal the signing key. What they breached was, it was more like they subverted the issuance process. And it wasn't that they jumped in the middle of the emails. It was that they actually got into the software module that controlled that process. And so they were basically able to even if they couldn't satisfy the validation process, they could trick the software into saying that they had satisfied it. And then the certificate the software would sign any certificate that they wanted. So they didn't just make Facebook. Once Google knew about it, then they could go looking, and they saw that they did a Google certificate, a Facebook certificate, and all the kind of high-profile websites at the time. Now, part of the problem, going back to revocation, is who revokes the certificate. So if you're Google and say you're your own CA, Google's big enough that they're their own CA, right? And they see a fake DigiNotar certificate out there for Google, DigiNotar is the one that has to revoke it because that's the bad certificate, okay? So another kind of problem with revocation is that the CA that needs to revoke a certificate is the CA that kind of screwed up in the first place, right? In the case of a CA breach. So that's another sort of added complexity that's kind of annoying about revocation. But anyway, so DigiNotar basically went out of business, and Komodo and all the browsers removed them. They removed their root certificates and things like that. And Komodo, so DigiNotar was like a small, I think they were in the Netherlands, they were like a smallish company. They didn't have a lot of clients. And so the hammer came down on them. But Komodo was actually a big CA, okay? And they had lots of, I think they had sub CAs and all sorts of stuff. And so the browser said, hey, we can't just go revoke Komodo. It's going to cause chaos. And so Komodo actually got to stay on. And so to this day, if you go looking through your root certificates, you'll find that Komodo's there. So anyways, market conditions aren't always fair, right? In this case, a lot of people were critical that they were treated differently, even though they basically committed the same error. But one was deemed too big to fail, and the other one, because it was smaller and foreign from the US perspective, then it was allowed to fail. So anyway, so that happened. And then this was high, like this was like in the news like level profile. And so the browsers and the operating systems also revoked it at the software update level. So they just, these certificates were removed. Now, all of this happened is because they went after Google and they got caught. And Google, they're powerful because they have popular websites, popular browsers, popular operating systems, at least on mobile, well, Chrome OS too. And so they control a lot of the infrastructure. So if you go doing fake Google stuff, there's a good chance that you're going to get caught, okay? But if you did it for Concordia, right, that's a different story, right? Like Concordia doesn't have a browser and not a lot of people go here. And even if Concordia noticed it, they could go over to a CA like DigiNotar and say, hey, there's this fake certificate for Concordia. And the certificate authority is going to be like, well, prove to me that you are Concordia, right? And so it's like maybe eventually you could get it revoked. That's the theory of it. But if you're a small player in this ecosystem, it also, it doesn't work so well. Okay, now what's the high level? So we spent, I don't know, 3, 4, this dragged out a little longer than it had in past terms, but we spent a lot of time on this attack tree, okay? So what's the whole point? Why did we spend so much time on the attack tree? Well, hopefully it was interesting. I think some of the attacks and things like that, it's interesting to look at something in depth. But there's a couple other attacks, or takeaways, I should say. So attack tree, takeaways. Okay, so this was a thorough example. Hopefully it demonstrates to you that you can't just, like if you did an attack tree without knowing as much as I know about HTTPS, you probably wouldn't have come up with all these attacks, right? So it's hard to do an attack tree if you don't have domain knowledge of what you're attacking. So it's not a shortcut from having expertise. Or domain knowledge is a fancy way of saying that you know what you're talking about. So that's why I can't teach you this one simple methodology and then you can go and apply it to anything, even if you don't know anything about it. Okay, and the main thing I like about attack trees is if we go back to the tree, there's actually quite a broad sort of set of attacks. So like you have social engineering, which is like tricking human beings. You have things like attacking DNS. You have using the legal system, right? You have all sorts of like software errors. And so initially when we write down the goal, you're thinking, oh, this is a software problem, right? Or this is a crypto problem, it's a crypto protocol. But then when you realize it, it's like, no, that CA is a bad company, right? Or that government can compel that private key from that CA. Or, I just have to go register SSL certificates at gmail.com and I can break all this crypto, right? Or I get your password for your DNS registry and I can break all your crypto, okay? And so the nice thing about the attack tree is it showcases the wide breadth of attacks, okay? So it's not just technical attacks, it's non-technical attacks as well. So technical could be like crypto attacks, like network level attacks, software. And non-technical could be things like social engineering, government. Password guessing is kind of technical, but like can be done in a non-technical way, like just looking over your shoulder or whatever, right? Okay, and then a few observations about the attack tree itself. So if I did the attack tree and gave it to you as opposed to asking you to do it yourself, it's still a nice format for you to look at, okay? First off, you notice that, for example, if I can guess your domain registrar password or I can guess your email password, those attacks are very similar, right? They both get me the email automated verification, which gives me a valid certificate, which allows me to subvert server authentication, okay? So these two attacks are much more similar than, say, guessing your email password and Freak, right? Like those two attacks are a lot different, okay? So this idea of a tree is that you keep your sort of, your relatives close to you, okay? So you can sort of see related attacks. Another thing you can do is it can sometimes help you fill in where there might be an attack missing. So for example, what I like is, for example, if we go from subvert server authentication, and just look at all the children of just this one node. So the first one's like use a valid certificate, okay? And then there's all the ways of using a valid certificate. The next one is use an invalid certificate, okay? Use a revoked certificate. Use no certificate. So once you see that list, valid certificate, invalid, revoked, no certificate, you might think, well, what about an expired certificate? Or what about, what other kinds of certificates are there? So because you have that structure there, you might think of new attacks because it sort of categorizes things in a way. And you're like, oh, there's a missing category. We didn't talk about expired certificates. So, what are the attacks there or whatever, okay? So an attack tree can help you find, new attacks that are missing from your tree by bringing that structure. Because they're related to the attacks that you already have. Okay, and then the last thing is that an attack tree kind of tells a story as you move from the middle node out to like a leaf node, okay? And so this also it's nice to pick it up and read it because you can just go and say subvert MX record in DNS, right? And maybe you know what that means. You know what an MX record is, you know what DNS is, and so you know what that means, but what does that have to do with HTTPS, right? Well, the story's told in the path, right? So, my goal is to observe traffic sent over HTTPS, given that I'm in the middle. The way I'm going to do it is I'm going to try and get that tunnel pointed at me. So I'm not going to break into the tunnel. I'm not going to look at it from the outside. I'm going to get the tunnel pointed at me. Now, if the tunnel points at me, that means that I gave some sort of public key. Like, tunnels end at public keys. Okay? So I have some sort of public key. Public keys are signed in a certificate. And so what am I giving? I have some certificate, so what kind of certificate am I giving? Well, maybe I could give a valid certificate. If I could give a valid certificate, then I don't know how I'm going to get a valid certificate, but if I could get one, right, that the browser considers valid in the sense that the browser considers it valid, not because it's for, like, the key is bound to the right website, okay? If I could get a valid certificate that's actually my public key, and the certificate says that Google's public key is my public key as an adversary, then I can subvert server authentication and then I can achieve my goal, okay? So how am I going to get a valid certificate? Well, I have to get issued a valid certificate, and I get issued a valid certificate because it wants to send email to me. And so all I have to do is change the email record in the DNS record. Now the email comes to me. And so instead of going to Google, it goes to me instead. I answer the email. They believe that I'm Google. And because they believe I'm Google, they give me a certificate. It's valid. And then I go out as a man in the middle, and I get all the tunnels pointed at me, and then I can decrypt all the traffic. Okay? So anyway, the point anyway is that, yeah, you sort of get a story as you go from the root of the tree to a leaf of the tree. And every path has kind of a different story. Okay. Questions about any HTTPS stuff or any attack tree stuff before we move on to a different topic?
So different nodes will have different kind of attacks possible.
Yeah. So every node should be a different attack, but it might be very close to a node that's close to it. Like, the attack might just differ at that final detail. Whereas nodes that are leaves that are in completely different subsections of the tree will be unrelated. But every single one of those leaves achieves the same goal, right? So that's maybe something else that I could say that I didn't explicitly write down. But we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Let's call it 25 leaf nodes. And so I showed you 25 ways to break HTTPS. Okay? They all do the same thing at the end of the day. They all get you to where you want to be, which is to break it in the middle. But there are 25 completely different, well, mostly completely different ways, but some of them might be related. There are at least 25 different ways of attacking, and some of them are really completely different, and they touch on all sorts of different issues from technical to non-technical. And I can summarize all those attacks in a single data structure and give it to you to look at, right? And so that's what's interesting about it as well, is that all the attacks sort of hang out together, and you don't really notice the difference between them. Okay, any other questions? Great. All right, let's take a 10-minute break, come back at 4:20, and then we'll move on to a totally different topic. Again. All right, so now we're going to switch gears completely. And so I want to take a lecture or two and talk about social engineering. Okay. So first I'll define it, and then I'll say why we're talking about it in this course. So social engineering, you probably have an intuition about what it means. It's a term that we've thrown around a bit already. I'm going to say that it's gaining access where a human screens access. So they're making a decision about whether you should have access or not. And this can be implicitly or explicitly. So sometimes everyone knows that the human does it. And sometimes it's more implicit, meaning it's more indirect, right? People aren't really thinking about that human having that role, but at the end of the day, they basically have that role, whether they realize it or not. Okay, so in this course, I like to focus on issues that are important, but don't really get well covered in 6110 to 6140, okay? So 10, 20, 30, 40, you're going to learn a lot about technical things, cryptography, protocols, network security, operating system security, that type of thing, okay? But if you go out in the real world, let's say you work at a bank, and you see what are the actual attacks that happen, right? Are there people trying to breach our servers? Yes, there are, okay? But we have a bunch of products that we bought from vendors or some that we developed in-house, and they do a pretty good job, right? What you see is that, no, the number one attack is someone calls up and says, hey, I'm Jeremy Clark, and I lost my debit card, and can you send me a new one? This is my address. And of course, it's not me. Right? It's someone else that's impersonating me. Or can you help me? I'm trying to get this wire transfer through and it's not working. And can you just help me out? Okay. And so social engineering is a very prevalent attack. And then from a methodologies perspective, it's challenging because you can write antivirus software, right? That's fine. There's lots of techniques that you can learn about for detecting malware. You can use machine learning or whatever. It's a lot different to write anti-social engineering. Like what would that even be? It's not software. It would have to be like a policy or a procedure or something like that. And what would it look like? And then when you're done with it, how would you know if it works or it doesn't work, right? And so the methodology is really unclear, okay? And so I like to explore this topic just so that you get a grasp of it. You're going to see it a lot if you work in security. And I don't actually have a lot to tell you on the methodology side other than I want to convince you that it's a hard problem to come up with methodologies for. Okay? So basically it's prevalent. And there's no well-established methodology. For saying something is not vulnerable to social engineering. And part of the problem is, what is that something, right? Like that's even hard to define. Like if I say, oh, your computer's not vulnerable to malware, well, you know what the thing is that you're protecting, it's a computer, and then you can think about how you're going to protect it from malware, right? But here it's like, what is it that's not vulnerable to social engineering? Like a company isn't, the policies, the procedures of a company, like it's kind of vague what you're even talking about. People. Okay, things that don't run software. It's not software or hardware or protocols or any sort of hard technical thing. Okay, So before we come back to the methodology, let's try to understand the problem. So what I'm going to do is I'm going to give you some quick examples. Then I'm going to give you a taxonomy for the sort of components. We're going to break social engineering down to 4 components. Then we'll watch a video just to sort of start thinking about it. We'll think about what those 4 components are in terms of that video. Then we'll go through each of the 4 components in more detail. I'll tell you everything I have to say about each of them. And then I'm going to tell you like 10 stories, probably not this class, but next class, about social engineering. And we can think about sort of what they have to do with how you would categorize them and what you could do to prevent them and things like that. Okay, so what are some examples? So we've seen some social engineering already. We saw, for example, if you have a certificate authority and they're doing in-person validation, then an ex-employee of Microsoft can walk in and say, I want a certificate for Microsoft and get it. A common thing is some sort of impersonation. So you might say, I want to access, there's a company I'm trying to break into their servers. And of course I can see what operating systems they're running and see how their network's set up and try and get in that way. Or I could just walk into the front door. I could dress up like I'm IT support. I could maybe watch the building for a couple days, see the company that does their IT support, see the van go in with the logo, look at their uniform. I'll come in with the exact same uniform, the exact same logo. I'll have my network NAT reader scanner thing attached to my belt or whatever, right? And I'll just be like, hey, I heard there's a problem with your servers. Where's your server room? Okay. Then I go in and do God knows what.
Or it can be a phone call.
Yeah, yeah. Another example is, let's say I'm targeting the same company. So I tried the network thing. I tried dressing up like IT. Here's another thing I could do. I could just grab a bunch of USB keys, put malware on them, and just throw them in the parking lot in random places. Okay, what's going to happen? Somebody's going to be walking in the building. They're going to step on it, and they're going to be like, oh, somebody must have lost it, right? So what are they going to do? They're going to pick it up, put it in their pocket. They're going to walk in. They're going to sit down at their computer, stick it in, and let's see if we can find out whose this is so I can give it back, right? Meanwhile, the malware, makes its way into the system. So we call those road apples. So a high-profile example of this is there was a thing called Stuxnet. You might have heard of malware. So this was in Iran. There was a nuclear enrichment center that was supposed to be only for energy, not for weapons. Other governments, it's basically speculated that it was the U.S. and Israel, decided that no, they were doing it. They were enriching the Ukrainian or the what's the word? Uranium, sorry, thank you. And so they were enriching it for weapons or whatever, okay? So they decided we're going to do a cyber physical attack, meaning we're going to attack the computer system, but the computer system is basically going to somehow damage the physical components that are involved in enriching. Basically, they're going to spin them really fast, but the computer system is going to say that they're spinning slow. And so you won't be able to know, and then they're going to burn out or whatever. And so it was a successful thing. Anyways, it's speculated that the very start of this attack was done this way, okay? And so the problem with them is that they were not connected to the internet, okay? So we call it air-gapped, the components. So you needed someone to physically walk something over the air gap into it. And so it was speculated that initially It was this road apple approach that got a predecessor to Stuxnet on the system that just did monitoring. And so they were able to figure out how the whole system worked and what components are used and things like that. Then they came back with Stuxnet, like the malware that was specifically targeted for those exact components down to the like manufacturer of the components that were used and things like that. So anyway, so that's a very high profile geopolitical example of road apples. A more down-to-earth approach, which is no less effective, is malicious emails, which I'm sure everyone in this room has gotten. So you could have malware as an attachment. That doesn't really work so well these days. Unless if you're running your own mail server, most mail servers that you use are going to be scanning for malware. It could be like they just try and convince you to take an action. So it's not malicious in the email itself. It's just impersonating coming from someone else, and they want you to, go over and, I don't know, open the server room or something like that. The more sophisticated types of emails we call spear phishing. And so depending on how your mail server is set up, there are some defenses against mail spoofing, but it also could be quite possible you could receive an email that your client displays to you as having come from j.clark@concordia.ca. Okay? And so that's what we call spoofing. So that may or may not be possible. It comes down to this protocol called DKIM, and there's problems with DKIM itself, but we won't get into those. But basically, a spear phishing email would be targeted exactly at you, and it would know a lot about you. It would know the kinds of people that you're interacting with. So, for example, if you're working at a company, it might CC in your colleagues, and they're the colleagues that would normally be CC'd on the email, right? There might be an attachment, like, say, an Excel file or something like that, and it would be relevant to your job. It would be exactly the kind of file that you would expect to receive over email from the person that's sending it to you with these exact people CC'd into you, okay? So that's called spear phishing. It's a highly targeted type of email. And then it might get you to try and take an action, or there might be malware. So sensible attachments, that kind of thing. So it's not like some weird email that's, in broken English and is promising you $100,000 if you just give your banking details and things like that. This is like the other end of it. So it's highly personalized. A lot of companies have customer service over the phone. The person on the other end of the line, you have no clue who they are. You can't see them. Can't check their ID. You want to authenticate them somehow, it's going to be based on what they know. If they know a lot about you, right, then they could probably convince them. Or they could just try and persuade the customer service, right? Like, this is a really urgent issue, or there's some emergency, or there's some extraordinary circumstance, and you really need to do this thing for me, even if I can't tell you the last 4 digits of my credit card, or whatever the case may be. So you're going to persuade a human to take an action. And excuse me. Depending on the company, depending on the company procedures, I'll find my voice in a second. Okay. Depending on the procedures of the company, these reps could be very powerful, right? They could have the power to do lots of changes and password resets and that type of thing. Okay, so there was actually a pretty good book written about this called The Art of Human Hacking And I read the whole book, and there was a lot of stuff in it that was kind of junky as well. And so I kind of distilled out what I thought were like the 4 major components of a social engineering attack. So social engineering doesn't have to have all 4 of these, but most of them have flavors of them, or they have at least 2 of the 3 type of things. So it gives us a nice way to sort of categorize what we're thinking about. So we're going to go through these in detail. I'll show you a video, and you can sort of get a feeling. We'll talk about just the video, what these 4 things mean in the context of the video, and then we'll do a deeper dive on each of them. But at a high level, information gathering would be like, if I want to send you a spear phishing email, I got to know something about you, right? So where am I getting that information from? That type of thing. So that's the sort of information gathering part of it. Pretexting is a fancy word of saying, it's a fancy way of saying pretending to be someone else. So if I show up dressed like an IT staff, that's called a pretext. So the pretext is that I work for the IT, but I don't. Okay? So that's also used a lot in social engineering. And then the final thing is, what am I actually trying to get? Right? Like I'm not dressing up because it's Halloween and it's fun, right? I'm trying to get something from you. Okay? I'm trying to influence you in some sense. And you can break it into 2 goals. Okay? One is, I'll call it persuasion, which is I want you to do something for me. Okay? Like give me access to something. Okay? And the other is called elicitation, which is to learn something from you. So I'm doing all of this stuff because you have some information that I want to learn it from you. Okay? So I either want you to do something or I want to learn something from you. Okay? Okay. So the guy who wrote the book, Art of Human Hacking, he also had this TV series that was on in Britain. I never watched the series itself, but he mentioned in his book, he particularly liked one of the it's like a reality show. And so they do these social engineering attacks on people and video record them. And so he mentioned this one, and then he kind of used it as a running example through the book. And so I liked it. So I thought, let's watch it. And then we can think about, as you're watching it, think about what's the information gathering, what's the pretexting, and what's persuasion and what's elicitation, and we'll go through them. Now, the challenge, just so that you can think a little bit about it, is the goal of the social engineering attack is we're going to go into a public place, pick a target, and we want to get their bank card, okay? That's relatively easy. I mean, there's all sorts of theft or different ways of doing that. But what we really want to do is we want to get their PIN as well. Because if we just have their card and we don't have their PIN, then we're in trouble. Or like we can't really do much with it, okay? So think in your minds, how would you social engineer someone into giving up not just their card, but also their PIN? And then ideally, just to put some rules on it, no violence or crime or anything like that, okay? So this is just, it's still illegal, right? Impersonation and pretexting can be illegal, so it could run afoul of all sorts of laws, but no violence or coercion. And the best attack would be one where when it's over, the victim doesn't know that they were attacked, okay? So they walk away having been attacked, but not being like, oh, I just got scammed or I just got frauded, right? In fact, they might even feel good about what happened relatively, despite the fact that they lost their card, okay? So anyways, you can think in your mind about how you might do that attack, and then and then we'll watch the show, which shows you one way of doing it that's interesting. So now let's do the more academic exercise, and we'll think about what you just saw and how does it fit into this categorization, and then we'll spend some more time on each of the things. Okay, so information gathering is the first one.
And the man in the briefcase started asking
Okay. So he did ask her about the bag. Now I'm going to put that under elicitation because this is sort of after. This was an attack which was about gathering information from the victim themselves. Information gathering is more about before you even do the attack. What do you need to know? Okay, so like what kind of research would you have to do? That kind of thing. So this attack is actually pretty light on information gathering. So that it has more in the other categories. But for information gathering, there's some basic things like they chose a mall, right? So they knew that would be like a food court would be a good place to find someone. They were probably familiar with the food court, or at least they looked around. They knew where the exits were. They knew where the van was relative to the food court, like that type of stuff. Yeah, okay. Then they found someone that they found the victim themselves, right? And so this is someone, it worked well because she was alone, right? And it worked well because she had a handbag and it was on the chair beside her. And if they could pivot her attention away from it, she would take her eyes off of it. So if she had been there with a group of people, I guess there was someone else there, but they went to the washroom or something. It didn't quite say. But being alone means that she's the only one watching the handbag. And then, of course, if her wallet's in her pocket or something like that, then the whole attack isn't going to work as well. So the handbag on the chair. And the final thing is that the pretexts that they use, so we'll go through them, but you do have to know what you're doing, right, with the pretext. You have to know what a call center sounds like or whatever. So that also is kind of part of information gathering as well, as just arranging your pretext so your pretext will be realistic. So background on any pretext that you'll use.
Automated recording.
Right, exactly. So let's list them out actually now. Okay, so pretext is I'm pretending to be someone that I'm not. There was more than one pretext that was involved here. What were they?
The man pretended to work for the bank, and the other one pretended to be customer service for the bank.
Okay, so we have the banker, the guy with the briefcase. We have the person that's on the other end of the line pretending to be customer service. So that's two of them. Was there any others? Okay, there were tourists that asked for the picture. They weren't actually tourists, so that's three. And is there any more? So there's one more, you just mentioned it.
Recorded message.
Okay, so this arguably is maybe the same as the customer, but that automated service was kind of a new pretext. The service agent's like, oh, I can't take the number off you. You have to use the system or whatever. And so that was the pretext. Okay. So there were the tourists. There was the bank employee. Okay, did you believe that he was a bank, that he worked for Barclays or whatever he said?
Yeah, he was dressed like.
Okay, he looked like a banker, whatever that looks like. He had a suit, briefcase. He was confident. He sort of took control of the situation. And he seemed to know what he was talking about. You know, he's like, oh, I know the service customer. You know, I have it on my phone or whatever. So he seemed to have the knowledge.
Gain trust.
Yeah, gain trust. So this actually maybe is less about the pretext, but you might trust someone that's in a suit with a briefcase more than you would trust someone else to help you. So that kind of goes into the pretext, but it also kind of goes into how he was able to influence the person. Right. Okay, here's something else that I thought of that I've seen used before, but they didn't really, I'll call it an add-on that they could have done. So another, if you want to convince someone that you work at a bank, for example, Normally you wouldn't show them ID. You might not even have ID, but you might give them a business card. Now, a business card doesn't mean anything, right? Anyone can have any business card with any name and any company on it. But people, somehow that seems like a sort of trustworthy. When people accept a business card, they're like, oh, this person really works for the bank, right? So in this case, he didn't know what bank she was with, right? So you could, maybe in the information gathering stage, you could pick someone who, maybe there's a bank in the mall, you follow them from the ATM and then they sit down in the food court and that's how you choose your victim. Or an even easier solution is, I don't know in the UK, but let's say there's 5 major banks, right? You have a business card for each of them, right? And when she says, I'm at Barclays, you're like, oh, I'm at Barclays too, and you pull out your Barclays business card and give it to her, kind of thing. So that's another sort of trick that you can do that adds to the pretext. It's cheap, easy, and it adds, you can't help thinking that it's legitimate when you receive it, even though there's nothing authentic about a business card at all. And then you also sort of gain trust. They're like, oh, now I know your name and I know like you have your phone number and stuff, even though that could be completely made up or whatever as well. Okay, there was the call center operator. Okay, what did they sound like a call center operator? Like what added to the authenticity of the pretext? Okay, so they had the background office call center noise. It's a weird question, but did they sound like someone that you might talk to on customer service, like in terms of their voice and things? Yeah, they kind of like droned on. When they said things, it sort of sounds like they'd said it 100 times before, that type of thing. So it sounded scripted. Kind of bored, like they want to help you, but they, it's their job or whatever, and they've been doing it for 5 years or whatever. And then the automated system, which wasn't actually, it had that sort of Siri voice, robot voice or whatever. And so it maybe seemed legitimate. Okay? So these are all things little small details that go into the pretext. And the better you can pull off the pretext, obviously, the more chance an attack will be successful. Okay. Then the third category is influence. And this is basically an elicitation attack. I'll put it as 3.2. You're trying to get the PIN from them, which is you're trying to get information. You're not trying to persuade them to do something necessarily. Well, first off, was there any persuasion component to the attack?
Yes, persuasion to speak with the bank.
Okay. Okay. So let's list that. So she could have whipped out her own cell phone. Now it was probably in her bag, right? Or she could have said, oh, there's a Barclays upstairs, so let me just go up there and cancel it. But she used the banker's phone. So that was persuasion. The other thing that was sort of moderate persuasion was with the tourists, what was the whole point there was to get her to look away from her bag, right? Persuade her to not look at her bag. So that was a kind of persuasion as well. But the main thing was elicitation. Okay. So what were the sort of factors that went in? Like if you just walk up to someone and say, hey, what's your bank PIN? They're not going to tell you, right? But in this situation, they were happy to do it, right? So there's something different about the circumstances. So what are those differences that would help the person try and if you're trying to elicit the information that would sort of help that process as opposed to hinder it? Okay, so one thing is that they care a lot about it. They have a goal in their mind, right, which is to cancel their cards, okay? And because it's money, it's stressful, right? It's their life or whatever too, okay? So when you're acting under pressure and under stress, and in that situation, it's not actually that stressful in the sense that if you waited 3 hours and canceled your cards, probably wouldn't make a difference, right? But when you're in the situation, you're not thinking that way because you're not thinking rationally, okay? So people who are under stress will think differently than people who are not under stress, okay? And that can be part of elicitation or persuasion. So social engineers will often try to induce certain emotional states in their victims in order to get them to give up information or do things that they wouldn't normally do. Okay, so they created a stressful situation. It was kind of, they gave the idea of time sensitive, like I think he said something like, you still have time to cancel your cards, or like kind of playing that idea, like if you wait too long, then maybe someone's going to use them. So this is time sensitive, you've got to do it right away. I'm giving you a way to do it right now with the phone, right? And so that addresses that need. You might not think critically. Okay, there's this sort of, in social engineering, we talk a lot about rapport, which is kind of a weird word, but a rapport is kind of like your relationship with a person, but it's usually like if you know someone really well, maybe you use the term, but rapport is usually, like I think of it as more like I met you for the first time, did we kind of get along, right? If we got along and I told some jokes and you laughed at them or whatever, I'd say we have a good rapport. Okay, so rapport is kind of like how you got along. So between her and the bank employee, did they have a good kind of rapport, right? And so the answer is yes, because he was very confident. She wasn't. He sort of took control of the situation. She was happy to have someone, grateful even to have someone take control, and then that led to her being happy to use his phone, which was the ultimate like sort of problem with it, right? So the sort of confidence, he seemed to project like he knew what he was doing. The helpfulness, right? He could have said, oh, you're stupid, why'd you lose your bag or something, and then probably it's not going to work, right? Right, and then he offered a quick fix, right? So time sensitive, you sort of induce the idea that you need to do something quickly, and then I'm handing you the phone right now and you can do it right away, right? So that's hard to turn down. And if you did turn it down, you also risk offending him as well, right? And so that might not, like maybe you have no problem offending people, but it's kind of a slap in the face to say, oh, actually, I don't know, maybe you're not who you say you are or whatever, right? And so that also, if you have a good rapport with someone, you might not want to say that even if you're thinking it in your mind. So you might want to avoid offending. Someone trying to help. Okay. So then basically the end of all of this is she takes the phone, right? So now she has the phone. Now she's talking to the person, the customer agent. Everything seems good. So the pretext is good. And she's expecting them to ask the information that they ask. Okay. So everything is sort of, her expectations are being matched, basically. So. And then comes the core part, which is we need the PIN, okay? And so what they decide in this pretext is they're going to give it to the automated system and have the automated system take the PIN because the employee says, I can't take it off you myself, okay? Okay, so there's two things about this, both pro and con. The part of it that's sort of problematic is, from an attacker's perspective, you are planting that seed of doubt in the person's mind when you say, I can't take the PIN off you, right? As soon as you say that, you get them thinking about security. They're thinking about, oh, yeah, my PIN, it's a secret, right? So there's a name for it, which I'll have later. Let me see. Preloading, we call it preloading. So the idea of, and you can use that to your advantage. Like if you want something, you can sort of preload it in the conversation early on, just to sort of get the person thinking about it, not sort of subconsciously, okay? And so they sort of did preload the idea that a PIN was sensitive information. And so that maybe wasn't the best approach to doing it. So the automated system. So a better attack might avoid this, but you can rack your brains about if you can avoid this step. I don't know that you can. But then they ultimately had a solution. Their solution was you're going to type it in with your cell phone, like with the numbers, to a robot as opposed to telling it to a human. Now, is that actually more secure? Right, like so we saw that it wasn't like in the context of the attack, but generally would you be more willing to give a piece of secret information if you think you're actually dealing with the real bank? Would you be more willing to give it to a computer as opposed to a human? Yeah, okay, so there is something that feels more trustworthy about it, or it feels like the person can't just turn around and start stealing your money or something like that. It's going into a computer system. So they had that aspect and they were able to pick up on it. I don't know how you would describe it, but it seems more trustworthy to give it to a computer instead. And then in this case, it worked, obviously. Okay, so that's an example. Now this is like,
I have a question.
yeah, go.
Can we just verify, like over the phone? Because there are a lot of instances when like I've been asked for SSN over the phone for different things. So is there any particular we can verify that it's actually from maybe the government or a valid person?
Right. So there's a few things that you can do. So the first thing is that if someone phones you, it's very different than you phoning them, right? So if you're on with customer service, you looked up Bell's website or whatever, you found their website, you found their number, and you called them, then you can be reasonably sure that they're actually Bell, right? Then in terms of what pieces of information they use to authenticate you, so like no one should know your social insurance other than, unless if it's some sort of government thing, I mean, you just never tell it to anyone. Your bank knows it maybe like for tax reasons. Like Concordia knows mine for tax reasons. So I guess you have to think a bit about like, would they even know this piece of information?
Yeah, but there are instances when like you call and they would ask to call. They'll say, "Do you want us to call you back?"
Right.
At certain times, like that's happened to me a number of times.
Yeah.
And they ask for your information afterwards.
Right.
How can we be sure that the person calling you back, it's a coincidence, maybe not, that it's actually from the government, because I think I can't remember what I was trying to register for. I think it was RAMQ or something.
Yeah.
And they asked for like social insurance numbers.
Right. Yeah, so callbacks are dangerous. Now, to attack that, like you say, the adversary would have to attack in that window between when you called them, because that was legitimate. So they are going to legitimately call you back. The only question is, could an adversary call you back first, but then also like happen to be impersonating the very service that you're trying to get? So there is an attack, there's a vulnerability there, but it's kind of limited, both in time, and they could only attack you with like RAMQ or whatever the case may be. But yeah, callbacks aren't great. It's better to, get your business done when you call them in the first place. Yeah, and then, so you have to think, and then in this example, actually the PIN, like they said at the end, the bank doesn't know your PIN, right? So if you know that you should never disclose your PIN, period, right, then that's fine. And so so anyways, yeah.
To give benefit of doubt to the attackers, I feel like probably using the computerized voice to let the victim type in the PIN was part of the information gathering phase, wherein they call the bank first, and then this was the bank's protocol to get a PIN from the customer. So just to make the person believe it.
Right. Yeah, absolutely. Yes. Yeah. So in information gathering, we said background on any pretext. So what does a bank employee look like? You have to know. What does the automated service, the real one, actually sound like? And if you could even record it, right, and use the real one, that's even better, kind of thing. Yeah. So absolutely. So the information gathering involves all the pretexts and trying to make the pretext as realistic as possible. Yeah.
Does this fall into information gathering, like monitoring the target to like know the right time to distract her and steal her eye?
Yeah, exactly. Yeah, so that monitoring, like waiting till they're alone, handbag on the chair, that was sort of meant to be it, but more general. And it's not just like you're also choosing the target too. So like you walk into the food court, there's 50 people that you could attack. You're going to monitor all of them, and then you're going to say, okay, this person just, now they're alone and their bag is still there, and so they're the one that I'm choosing, type of thing. But yeah. So casing like is part of information gathering as well. Yeah. So we didn't explicitly put it, but we could do it as well. Yeah. Well, I'll add it as targeting or casing. Say someone that's vulnerable to this particular attack, where the vulnerability is that they're alone and they have a bag or whatever the case may be. Yeah. Okay. So anyway, this is the framework. So next class, what we'll do is I'll go through each of them in more detail. I'll tell you lots of stuff about each of them, and then I'll tell you 4 or 5 other stories, and I have some more videos and things like that. And we can think about what these categories are in terms of these real life attacks. Okay, so I'll see you all next week.